Hello again, everybody. This is Steve, coming to you with, this time, not something with writing, but this is another one of my mechanical puzzles. This is one I've been working on for a long time, have yet to be able to build this, just because, no place to build it, and no money, and I need the parts, and there's a long story. Anyways, long story short, what is this? Well, or I should say the main question is, what is this? Well, some people would call it a potato gun. This one, though, is not a potato gun. Kind of is, but kind of isn't. What this is this is a soda can punt mortar. So yeah, potato gun more or less, but different design. So how does this thing work? Well, the long and short of it is, if you've ever seen a punt mortar, if you haven't, go look at I think it was The Thin Red Line. There's a couple other movies where they had this little one-man portable 40 millimeter short-range mortar. I mean, this thing only fired a few hundred yards. I mean, it did not have the range of a normal mortar, which is, I think, like 3 to 5 miles. It was designed for close-in support for infantry, where you just basically, you had one guy carrying the mortar, one, two, three guys carrying ammunition, tiny little round. I know a place that you would see it is in Saving Private Ryan, because that was a 40 millimeter punt mortar. They don't necessarily call them a punt mortar, but that's kind of the tongue-in-cheek name that's been given, because it takes these little 40 millimeter rounds and kind of punts them a short distance, hence the name. This right here for the potato gun design is or soda can mortar design is kind of interesting, because it's not like you put the soda can in here and you fill this with butane and bang, and it shoots out like it. No, this one you can actually repeat fire by doing nothing more than dropping a soda can in the tube. I kid you not, that's how this design is set up. So basically what happens is you drop a soda can, and this PVC pipe is roughly sized to a soda can. Soda can's a little bit smaller. If I remember correctly, this was a 3-inch Schedule 80. I think if it was a Schedule 120, it would probably fit a little better, but at the same time, you don't want it so tight that the can gets stuck going down, because then you really got a problem. Because if it gets stuck going down, it's going to get stuck going out, and you're just going to have a big mess on your hands. And then you'll have to tear it all apart and pull the can out and try again, or you might have to take a few thousandths off of the inside with a mill, and that just gets messy and stuff. So when I designed it with, I believe, if I remember correctly, it was a 3-inch Schedule 80 PVC pipe on the upper part right here. And it was designed so that just the average Joe could build it. This right here is the legs. Basically it's a bipod. The bipod just holds it up at the angle you aim it at. This right here is 6-inch Schedule 80 or Schedule 120 PVC, whichever one you want. 120 gives you a little bit more pressure, but Schedule 80 should do the job. I've seen them pressure test them up to 400 or Schedule 80 up to 400 psi, and it held fine. You ended up with a grenade afterwards, but it held pretty well to 400 psi. So, and really what you're going to be doing with this, you're not going to be running it at 400 psi. You better not be running it at 400 psi, or the sheriff's going to be having you do a little explaining as your punt mortar explodes. You should probably be running this at no more than 120 psi, tops. Safety factor, safety margins, keeping you from earning a Darwin Award, etc., etc., etc. All reasonable, logical reasons why. So anyways, what you have here is you have the main tube, and then you have the air canister down here, and you drop the can in the top. It comes down here, and then right down about here, there's a lightweight dead man switch. Dead man switch is basically it only is closed so long as there's pressure on the switch. As soon as you release the switch turns off, and the circuit opens up, and everything stops. So why the dead man switch? Well, the dead man switch is to run this, which is a what's called a normally closed valve. In other words, the valve by design is closed by default. And you can get the electrically actuated ones. And what you want to do is Now my design has it inside the tank. If you can pull that off and still get the wiring up here, go for it. But when I'm going to do it, what I'm going to do is I'm going to have the tank, and then I'll have a little nipple up here, pipe nipple, and then I will have the valve, pipe nipple, and then this here, and it'll be like just a couple of flat ends or rounded ends on each of these here, probably with a little bit of supporting material going in there to hold that in place, because you put a neck on it like that, you're going to create a weak spot. So I'll probably have some kind of reinforcing in there when I actually do mine. But basically that comes down, the soda can comes down, hits the dead man switch, opens this valve, and all this air in here goes woof, and at the same time that can goes wee. Now the design I came up with allows you to fire either full or empty. Empty, those are easy. That's cheaters work. The trick is to get a full soda can, which weighs I think about 16 ounces or about a pound, and launch it out of there with just 120 psi. So your valve down here is probably not going to be a normal 3/4 inch normally closed electric valve. You're probably going to, since this is 2 inches up here, you're probably going to want this valve to be 2 inches as well, just so you get maximum airflow up the tube to throw that soda can downrange as fast and far as possible. You'll probably only get 100, 200 yards out of it, but still, it's the fact that you can actually, fire automatically. And then what happens is when this discharges, as soon as that, this part I still got to figure out, because I know just doing the math, and I know I suck at math, but I'm pretty sure I got this right. When it hits this dead man switch and this opens up, as soon as it releases off of here, this closes. Well, that means you're going to have just enough pressure to like, brrr, and then it'll go do 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 do, brrr, do 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 do. So, you're probably not going to want that. So what I'm looking to do, if I can figure out how to do this, is you'll have the switch here, and of course it'll go down to like a little battery or something down here. I didn't put the battery in there because I haven't decided if it's battery, if it's AC, what it's going to be. Probably have to be AC because I'm pretty sure 12-volt battery isn't going to cut it. Plus you got this guy over here, so you're probably going to have a generator nearby running, or generator or electrical current running 120 volts. So you could probably have a normal 120 volt valve and plug into that, plug this in, off you go. So, but anyways, what it is when that dead man closes, since the dead man switch is like 12 volts, you're going to want to connect that to a relay, and then the relay has the wiring that connects to this valve here and your electrical connection that plugs in wherever it plugs in at, your wall socket or whatever. But what the design would be is when that's tripped, it would trigger, I would say, a 1 second delay. 1 second should be enough to get the thing down the tube. If it's not, you probably need to do some changes. But because when that thing is tripped, it should clear here in about a third to half a second, I'm thinking. Again, I have not built this, so if you guys want to build this and test it out, let me know how it works, please do. But based on my calculations and the math and other stuff I've done, that should clear the barrel in a third to half a second, which means if you hold it for a full second, you're going to drain your tank, but you also ensure that if it's not, but if it takes longer than a second to go out of the barrel, you're still going to have plenty of air flowing into the tube to get that can off the end of the tube and into the air. So, and you can, if you get a timed valve switch like that, where as soon as it opens, it runs for X amount of time and immediately closes the switch, regardless if the dead man switch is closed or not, then you're good to go. And like I say, you could probably adjust that up or down to find the precise amount of time so that you don't waste air out of here. Now the thing with this is it's going to be connected via a I would do a compressor nipple. Compressor nipple, if you're wondering what that is if you've ever dealt with an air tool, that little it's a little nipple thing that plugs into like these here. It's on the end of your air tools and stuff like that. So what you would do is you would put that down there, run a hose over to there and hook it in. That way This compressor, as soon as your motor goes boom, that compressor is immediately refilling this. And like that first, I can guarantee you're probably going to use enough air volume that you're going to go from about 120 down to about 60 psi. At which point in time, this dude's going to immediately start bringing it back up to 120. It probably won't go to 120 immediately, but like if you have this capped at 120, as soon as that fires, this is going to and it's going to start pushing air back in there again. And I don't know what the fire rate would be on this. You'd probably have to put a pressure valve on the tank to know how much actual pressure's in there, or you could just use the pressure tank or the pressure valves off of the compressor, which probably would be the better one, because since the two of them are connected, they're going to have, it's going to be an accurate number. Yeah, either way, because believe me, that hose may not be very big, like 1/2 inch, I think. But as soon as the pressure drops in here by 1/3 to 1/2, that air in here is just going to go right over into here. Because got to remember, this is still going to be 120 psi. And then this is going to be like 60 psi. So that's going to equalize real bloody quick like. And then that compressor is going to sit there trying to bring it up to 120. One other thing I don't show on here, which you probably want to build into your design, and I wouldn't necessarily build it into this housing because you've already got a weak point up here. Oops. Got a weak point up here already with the valve and the nipple and all that stuff up here. So you wouldn't want to put a second one down here because again, you're trying not to turn this thing into a grenade. So what you want to do is probably build a chassis, something for this to sit in, because when this goes whoop this way, obviously physics, equal and opposite reaction. So it can goes this way, mortar goes this way. So you're going to want that mortar to have something to sit in that will absorb that oomph or that little boom when it fires. Now, like I say, depending on how much air you can put into this thing and how fast you can put it in is how fast you can repeat your fire. If it takes like a minute to come back up to pressure, which it may, your fire rate is 1 per minute. If you had it where you had 3 or 4 of these hooked up, or you had something that was like say the compressor itself in the tank is 150, 160 psi, maybe 200 psi, but the regulator's set at 120, you're immediately going to have all that air going, and that will refill pretty downright quick like. Because, once it hits 120, the regulator shuts off and it doesn't fill it any further, even though the main tank is maybe 150, 200 psi. Again, that depends on what the max end of your compressor is. Don't go above your max end of your compressor. Don't go and knock on the door of the max end of your compressor, because you're putting strain on the compressor in the storage tank that you really don't want. So if it's like 180 top end, you probably want to dial it up no higher than 150, 160 psi. Because if it's, like I say, 180 maximum working pressure, you don't want to have it sitting up there for too long. Maximum working pressure means that that's as high as it'll go, but again, at that point you're putting unnecessary stress on your welds and your tank and the metal and the compressor and stuff. So yeah, 20 psi below would be the maximum I would take it to. Don't take it up to 10 below or right up to the max working pressure. Keep it about 20 below or so. But anyways, like I say, that will recharge and it'll recompress this. And as soon as that gets up at least above 90 psi, because I can run a framing nailer off of 90 psi. Works better at 120, but I can run it at 90 psi. So you probably could run this at 90 psi, because it would, with this you got not just the pressure, you got the volume of air. So air comes in here, recharges this. Next can goes in, And I think it would be kind of neat if somebody figured out a way, maybe instead of this being PVC, maybe you do gas line and it's all welded and you've got it reinforced in such a way that this thing could do 250 psi. Now the thing is, with the dead man switch, you'd probably have to cut a hole in the side, which is the way I've got it thought out in my design. Cut a hole in the side just big enough to fit this thing in there, and you'll probably have to mount that switch while the tube is off, because like I say, it's sitting way down here. So before you screw this into place, you'd put that in there. Probably hold it, or probably nail it down in place with like epoxy or something. And don't use a cheap plastic switch. The switches are all plastic now with like metal toggles. But at the same, but you can still buy really good quality ones, because you got to remember, when that dead man switch closes, you suddenly have 120 psi slamming against that switch. So now you also might run into problems, and I don't know because I haven't actually done this yet, but you might run into a problem where when that switch flies open, all that air going up the tube might grab that toggle and throw it or bend it up or something. So that's something else you got to think about. Again, when you guys build this, I'd love to see somebody build this and make it work. It would be so cool. And if, like I say, if you do, take a video of it, tell me what you did, show me. I think it would be cool. Yeah, as far as aiming it up and down, this is just, move this in and out. That's all you really got to do with that. Just move that in and out. Now, the other thing, too, is this is designed for a soda can. If you have other similarly sized materials that you want to shoot out of there, oranges, potatoes, apples, things like that, you should be able to. As long as it can roll down the barrel and hit that dead man switch and trigger it, you should be good. One idea that I've seen done before with high pressure situations, especially when there's going to be a sudden change in pressure, is to take this and wrap it in fiberglass held in place with epoxy. It's a fiberglass sheet. I can't think of what it's called, but it's a sheet. It looks like a woven blanket. It's made of fiberglass, and you smother it in epoxy, and you wrap it around there and let it dry, and it creates like a reinforcing. Again, this is if you're using the PVC. It creates a reinforcing barrier for that 6-inch PVC. If you're using like 6-inch to 2-inch like gas pipe or water pipe, something that's designed to take hundreds of psi pressure, no, hands down, no questions asked, you don't need that. Plus, metal pipe explodes. Fiberglass probably isn't going to stop it, and that's why I say that when you do this, do it, build it with the utmost care and think everything out. Think of every possible scenario, every possible failure. Because it's either that or you end up as a winner, and I don't want any of you to do that. So, and I might be overthinking this, and it might be completely safe. I don't know, but you got to remember, you're working with high pressure. So, always overthink it, in my opinion, so that nothing bad ever happens. I'm trying to think if there's anything else. I can't think of anything else right now, but that's the basic premise of this design that I have. And I thought you guys would like this. And yes, it's not a water pumping mechanical puzzle, but it is a mechanical puzzle. It's something fun I've always wanted to do, and I thought it would be kind of neat to share this with you guys because I think you would like it too. So anyways, that's all I got for this episode, and I'll catch you guys later.